In this video, I am going to do two example problems on titrations. So, looking at our first example, right, a zero point 0.8 molar hydrosulfuric acid solution is titrated with 31 milliliters of 0.3 molar sodium hydroxide, that's our base, right? The 0.8 molar hydrosulfuric acid is obviously the acid. We want to know what volume of hydrosulfuric acid is needed in the solution to neutralize the base. Well, some problems you're going to start out with the equation, some problems you aren't. So I'm going to give you two examples where you don't start with the equation written out. So looking at hydrosulfuric acid, you need to use your now naming skills to come up with it. It's made of hydrogen and sulfur. And because sulfur has a charge of +2 and -2, and hydrogen has a charge of +1, in order to get them to be neutral, we need H2S. We're going to add in our base, sodium hydroxide. Sodium has a charge of +1. Hydroxide, our polyatomic atom, has a charge of -1, so it's just NaOH. When the acid and base reacts, it's going to produce water and a salt. The salt is going to be the sodium, right? It's going to be the beginning of one and the ending of the other. So sodium and sulfur are making up our salt and balancing those charges, right? Because sulfur has a charge of -2 and sodium is +1, so we need two sodiums. So now that we have our equation, step number 2 is make sure it's balanced. We have two sodiums on the right, so we need two sodiums on the left. If you go through and you count the number of hydrogens, oxygens, of everything else, you'll see that ends up being that we have too many hydrogens on the reaction side, right? We have two, in the NaOH we have two hydrogens, on the H2S we have two hydrogens, so we have 4. So over now on the product side we need to balance it out, so we have 4 hydrogens. Now that we've got a balanced equation, now we can go through and start doing our math, right? So step 1, make sure you have an equation and make sure it's balanced. So step 2, you're going to take the known solution that you have and find the number of moles. Well, we know that we have 31 milliliters of 0.3 molar sodium hydroxide. So we know the molarity, right, is 0.3, and remember, molarity equals moles over liters. So our molarity of 0.3 equals our moles of NaOH, which is what we're looking for. And we know the volume, we're going to convert that volume into liters, so 0.031 liters. So doing your math, you end up with 0.0093 moles of NaOH. So our third step is to now take the moles of NaOH and convert it into moles of what we're looking for. In this case, we're looking for our acid. So using our balanced equation, we know that the mole ratio here for NaOH, right, we have 2 moles. So 2 moles of NaOH, and we have 1 mole of our acid. So our moles of NaOH cancel, and we end up now in the moles of our acid. So we're getting closer. Last step, step 4, is we want the volume of the acid. Well, we know the molarity of the acid, and now we know the moles of the acid. So using our molarity equation, again, we know the molarity of that acid is 0.8, right? We know that the moles of our acid is 0.00465. We got that from our step 3. and we're looking for our volume in liters. So rearranging that equation, right, we get 0.8 liters, right, times liters that we're looking for equals 0.00465. See if I can get a little more space. So divide this side by liters. Oops, I lied. Divide this side by 0.8. Divide this side by 0.8, right? And our liters are equal to 0.00465 divided by 0.8, which gives us a value of 0.0058 liters. That number is rounded to significant figures, which if you're looking, right, this has two significant figures, this has two significant figures, this has two significant figures. So the smallest number of significant figures, they all have two, so my answer is rounded to 2 sig figs. Moving on to the next one. So looking at this example, same idea here. We have a base, right, calcium hydroxide. So calcium hydroxide. I'm putting it in parentheses because I know that calcium has a charge of +2, hydroxide has a charge of -1, so I need 2 of my hydroxides to balance out. That is reacting with our acid, the chlorous acid. So using our naming skills, we get HClO2. H has a charge of +1. ClO2 has a charge of -1, so I just need one of each of those, so I don't need to add anything else to that. Of course, when we mix an acid and a base together, we get water, H2O, and we get a salt. To get the salt, we're going to take our calcium and our polyatomic ion over here, right? Mixing those together, we get CaClO2, and we need 2 of those because again this has a charge of -1 and this has a charge of +2. So we need 2 of our ClO2s. Okay, now that we have our equation, step number 2 is to balance that equation. So to balance the equation, what you end up with is, let's see, here we go. Right, we need 2. Right, we have 2 ClO2s, so by putting this 2 here, we get 2 ClO2s. That now gives us, right, 2 hydrogens here and 2 hydrogens here, so we have 4 hydrogens. So by putting this 2 here, I now have 4 hydrogens on the product side, so we have our balanced equation. So don't forget to balance the equation. Okay, step number, that was 1, right? Step number 2 is figure out the volume and the molarity of this known substance. So in this case, right, we know the volume and the molarity of calcium hydroxide. So we are going to use our molarity equation to find the number of moles. So 0.02 moles, 0.02 is the molarity of calcium hydroxide. It equals the moles of calcium hydroxide over the volume in liters. So we need to move that decimal over 3 places to get to liters. Using your math, right, 0.02 times 0.0152, that will give us 3.04 times 10 to the -4th moles of calcium hydroxide. So step 3, we are going to use our stoichiometry, our balanced equation, to figure out how many moles we have of our acid. So we have 3.04 times 10 to the -4th moles of CaOH2. Looking at our balanced equation, right? Here, there was only 1 mole of CaOH2, so 1 mole of CaOH2, right? And then our acid, right, we have 2 moles, So 2 moles of our acid. So of course, doing our math, 3.04 times 10 to the negative 4 times 2 gives us 6.08 times 10 to the negative 4th moles of our acid. Our last step, right, figure out the volume, or no, in this case, right, we want the molarity of it. So we're actually given the volume. So now in our equation, molarity equals moles over liters. We actually have the moles from step 3, 6.08 times 10 to the negative 4th. We have our liters, right? We have 10 milliliters. So moving the decimal over 3 to the left gets us 0.01 liters. That gives us 0.0608 for our molarity. Again, looking at the significant figures, right, for our problem, just going back up here, right, we have 3 significant figures here, we have 3 significant figures here, we have 3 significant figures here. So again, they're all the same, but you would choose the lowest number of significant figures, which is 3. So our answer has 3 significant figures. Hope this video helps.